Hello, everyone. Welcome to BSG's webinars. My name is Jake Keeler, VP of Marketing at BSG, coming to you from my lovely office in Eagan, Minnesota. Thanks for joining us. This is our third episode. Future episodes are posted on our website, as well as a link to the video recordings of past episodes. The page can be found by going to bsgcraft.com/webinars. And that'll take you to the registration for the future webinars, also a link out to the recordings. New episodes will air every Thursday at 1 p.m. Central Time. Next week, we have a long-term ingredient storage tips topic with Brandon Pierce, Quality Assurance and Compliance Manager at BSG. Throughout today's webinar, please ask questions through the Q&A function, center of the toolbar. If we have time, I'll pass some of those questions along to our guest, Chad Kennedy. You can also send follow-up questions to webinars@bsgcraft.com, and we'll send those questions off to Chad and get those answers back to you. So without further ado, today's speaker, Chad Kennedy, hop specialist at BSG Hops. His talk is entitled Hop Creep, Review, Research, and Regulation. And with that, I'll hand it over to Chad.
Thanks, Jake, very much. Welcome, everybody. Good afternoon. Let's see if I can not shake everything as much as I just did right there. I am speaking to you from Portland, Oregon today, my home office here, and got some lovely Mother's Day flowers back there for decorations. So I'm glad you could all join us. I will see if I can share my screen here, and we'll get started. Maybe. There we go. Back one. So yeah, today we're going to talk a little bit about hop creep and do a little bit of review of its history, a look at some of the research, and then also look at how we might deal with it in the brew house. So just real quickly, a little bit about myself. I am hop specialist at BSG, which means I work with growers and brewers, sort of in technical aspects. Reviewing crop conditions, seeing where things are, providing crop reports to everybody. Hopefully you guys see those on our blogs, websites, etc., and provides valuable information to you. And then also work with brewers on, kind of solving technical issues like hop creep, for instance here. So if we look at the definition here of hop creep, it's really, hop creep is kind of a new term. I believe it came, let's see, I think from the guys at Allagash were kind of the first ones that were calling it hop creep. And I've heard different names for it, VDK bump, second fermentation, but hop creep, diastase, and the freshening power of hops are kind of more what the current terminology is. And really what it is the re-fermentation of fully fermented beer, obviously after adding dry hops. And if you look back in history, and we will review some of this, that's perhaps where the term dry hop actually came from, is the drying out of beer after adding hops. And what this is really is an over attenuation due to adding hops. And what it's led to, which is really the challenge for brewers, is number one, an out of brand beer. So it's not within its brand specifications in flavor, specific gravity, and alcohol content. And really, with alcohol content, you can see bumps up to 0.5% ABV, which means then you're obviously out of TTB specs, and then you've got regulatory issues to consider as well. With that, obviously, are safety concerns, because obviously with that re-fermentation, if it's in a bottle, really is the biggest concern. You can see up to 2 volume increase in CO2 production. In that package, glass bottles weren't meant to hold that kind of pressure. And then you've got yourself safety concerns there if you've got packaging with that occurring. And we're also, some brewers see this more than others, and it kind of depends on the specificity of that brand, the beer style, mostly IPAs, but where that final gravity is, where we see VDK and diacetyl issues that are above threshold. So you'll have a beer that will pass, say, the sniff test or whatever kind of test you're doing in your brewery for VDKs, diacetyl. And you know, it's basically in the breweries that I worked at, it was a no-go test. And then all of a sudden, you know, a week, 2 weeks down the road, you've got diacetyl that happened. You'll run it through your standard micro in your QA QC, and no, there's no infection, so that's not the cause of this. So where was that coming about? And honestly, that's where in the more recent sense of when we see hop creep, that's kind of where people are really started to notice it, is that there was diacetyl in their beer, and where was that coming from? And that diacetyl is very slow to reduce because it's in a package at that point. There's little to hardly any yeast to uptake those VDKs. So you've got a real problem there with your packaged beer. And then obviously, as brewers, we're concerned about production and turning tanks in a timely manner. And if you've got beer that you know has got a lag time in fermentation, and then also has got challenges with diacetyl, you're increasing tank residence time, and you may be looking at a cellar where you thought you were going to get, you know, 7,000 barrels a month out of it, and now with these new hop creep challenges, you're only able really to get half that. So that can certainly provide a real problem for folks. So to kind of understand this a little bit further, we've got to look at mashing. And I borrowed this image here from a Brewer's Journal down at the bottom, and it was something where they were talking about brut IPA, which for the record, as we'll see here, is not really a beer that you're going to see hop creep in, although you may see some of your beers start to turn into brut IPAs with hop creep. That's a bit of an exaggeration, but start to tend to trend towards that way. So obviously in the mashing process, we're looking at degrading down barley starches through alpha amylase and beta amylase, are breaking down these amylase into smaller chains that the yeast you know, then consumes to produce CO2 and ethanol. And we won't go through the whole fermentation process. I trust that you're all familiar with that for sure. And these smaller chain up at the top here, these amylase, are what we consider to be the fermentable part of the mash. And that, you know, is a good portion of the mash here. And then the bottom, the amylopectin here, are really the starches, the longer chain dextrins that a brewer's yeast will not be able to consume. So that would be the dextrins, the body that is left over in the beer after fermentation. So yeah, on the right here, these mash enzymes, the alpha amylase and the beta amylase, are able to break down these amylase into smaller chain sugars that the yeast can consume in fermentation. And then there, in barley itself, pre-malting and certainly pre-kilning, there is a limit dextrinase in there that can break down these larger amylopectins, but that is denatured in kilning in the malting process, so they don't really exist. So that is important to keep in mind as we go through here and discuss what happens with hop creep a little bit. But yeah, the mechanism of action here that we're looking at is and I've got in here that current research suggests, but it's really at this point, it's been pretty well confirmed. There was a great talk the other day at the BA on their online CBC, which goes into a little more detail about this on hop creep if you're interested. Something to check out later for sure. And so what we're looking at is there's a diastase, a mixture of amylase enzymes contained in the hops, specifically in the bracts. So not the resins, not the oils, that can break down these larger chain dextrins into something that is fermentable by brewer's yeast. So these fermentable sugars then are metabolized by the yeast and produce the CO2 and ethanol and everything else that goes with it that we were discussing before. So in a real simple term, unfermentable dextrins plus the hop diastase plus active yeast, all these three factors must be included, will equal hop creep. Hop creep, as it were, is not a new phenomenon. We can go back, way back in time. And as I kind of alluded to earlier, hop creep has potentially been around since dry hopping. And Brown and Morris here in 1893, and I'll side note here is you can actually find this on Google Books. If you look down on the bottom right here, you can see the little powered by Google logo. So that's where I got a copy of these. The entire thing, all these old brewery texts are available on Google Books, which is a pretty fun way if you've got some extra time on your hands during lockdown and whatnot to browse through these. But Brown and Morris, some British brewing scientists were interested in this, and we all know the history of IPA, or potentially the history of IPA, that these beers were dry hopped in casks, put on ships and sent to India for the troops there, and they would see that these beers were, drying out, basically, continuing fermentation. Now, of course, they're on a boat, being agitated constantly, warm temperatures, in an open cask, basically, that's not airtight, and then on hops. So all those factors contribute to hop creep, as we'll see here too. But it's just interesting that in 1893, this is something we kind of think of it as a new phenomenon, from like maybe 2016, 2018, and certainly it's been around quite a bit longer than that. So what they noticed here is that that the higher hopping rates even then, and certainly now, have intensified the effects. And then, here we're talking about dry hopping and hops that dry out beer. Where did that come from? And that's potentially where the term dry hopping was. They posited that it was a wild yeast that was contained on the hops. We've since kind of disproven that, and that there were carbohydrates that were added to the beer from the hops, and that's true to some degree. If you were to measure the gravity of a beer immediately after adding dry hops, you'd see that there's a small bump in the carbohydrate, basically the extract. But that's such a minute part. That's not really a big part. But they did posit that there's a diastase that's going on from these hops, that something is breaking down these carbohydrates further. So interesting, in 1893. And then again in 1941, we've got the diastatic activity of hops with a note on maltase in hops. So that just, again, 1941, we've got this coming back up again. I don't know exactly why this was brought up again in 1941. Be interesting to kind of research that a little bit further. But in this instance, it did show that active yeast was important for this process to happen, and that a higher final gravity. So when the beer's done fermenting, if it's got a 3-degree Plato final gravity, that there's more potential for the hop creep phenomenon, as opposed to something that's drier. And that just makes sense again. So that 3 Plato has higher levels of those dextrins that these enzymes in the hops can break down further and then aid to further fermentation, as opposed to a beer that's already kind of dry. Again, when I said something about brewed IPAs not really being subject to hop creep, that's kind of what I was referring to. So we've seen a resurgence of hop creep, as I said, I've heard 2016, 2018, somewhere in that range. Some folks maybe were noticing it before, but it didn't kind of come together as a group until that time. And some folks have posited maybe why that has happened. Certainly pushing the limits of dry hop aroma with higher hopping rates. You know, certainly we've got, you know, when you're looking at a ½ pound versus 2 pounds per barrel, there's certainly more potential for this to happen because, as we'll see, more hops equal more potential for this, more enzymes in these hops. So brewers are also these days are dry hopping on yeast, which now you've got yeast, which, as we said, is a major component of this hop creep. You can have the breakdown of the dextrins, but if there's no yeast to re-ferment this, then there's no hop creep. Brewers are dry hopping traditionally at warmer temperatures, again trying to achieve higher hop aroma, and as I mentioned, higher hop doses. A lot of different varieties going on as well, and it has been shown that hop creep can be varietal specific. We'll talk a little bit about that down the road here too. And then just generally that brewers are chasing ways to get higher aroma and flavor extraction in their beer. At the same time, traditionally unbeknownst to us, we were also extracting more of these enzymes. So obviously an issue. Seasonal brewing is limited tracing hop creep, just that there's not a brand that you can trace, you know, over a whole year necessarily. Although you have seen more brewers that have been experiencing hop creep, which, you know, more brewers, more guys and gals brewing hoppier beers, then you've got, you know, more instances of this being called out. But just that you've got, you know, if you've got a beer that you brew once or twice, then you don't really get the back-to-back instances where you see trends of hop creep. And then there's changes from year to year too. A Cascade hop, 1 year that your brewery may have issues with hop creep, the following year or the previous year maybe it wasn't there. So all these factors really contribute into it's been hard to kind of have this come up as a new phenomenon. There's been also posited that grower and processing changes have led to an increase in hop creep, lower temperature kilning, and possibly pelletizing. I was just in the BA presentation last week. Vinny Chirluzzo from Russian River was positing that it'd be interesting to test if the pelletizing temperatures have come down and if perhaps that's doing it as well. But certainly killing temperatures at growers have come down from, so let's say, you know, 145 to now maybe 130 Fahrenheit. And the higher temperatures will denature the enzymes in the hops. So it's possible, again, as we've been chasing better aroma, we're increasing this hop creep trend. Kind of interesting, something we didn't obviously anticipate. But and then what I mentioned earlier, again, this leads to headaches, but extra brews, blending, you know, more transfers, obviously thus more cleaning, and has a high impact on your brewery's logistics and schedule, and headaches and probably sleepless nights as well. So we started to see a resurgence of research. Here I say 2015, I've heard, again, 2016, 2015. There hasn't really been a historian to nail this down. I don't know if we'll ever really get that, but brewers started to report seeing increased carbonation, alcohol, and as I mentioned, diacetyl. I think, to me, it seems that diacetyl in beers where it wasn't present before, was really the biggest issue. And then in 2017, we start to see presentations from the ASBC meeting here on, you know, what exactly is going on, and looking at how adding pellets as a dry hop to a beer will increase your VDKs and also lower the extract. And then in 2018, one of the newer examinations of this in the journal ASBC also posited this new term called the freshening power of hops. Specifically here, they looked at Centennial hops. Maybe the term hop creep wasn't always amicable to everybody, but Um, uh, so freshening power of hops here was also a term that was used by Brown and Morris way back in 1893. But what's most important here is it showed that as hops aged, that there was really no difference in the enzymatic power, and that there was varietal specificity to the enzymatic power of these hops. So Amarillo has been one of those, and if you're using Amarillo in your brewery, you may have noticed this, but Amarillo and Cascade, to a certain degree, but Amarillo definitely have shown sort of this higher enzymatic activity, this higher hop creep or freshening power of hops. And then interestingly enough, Simcoe Centennial Citra showed a lower FPH. But this was just one study done once. And again, as we posited earlier, it could be a difference in agronomics, post-harvest processing, varietal difference from year to year too. It's hard to kind of nail down where that's coming, and that's kind of where the research and the work is going into this now. They also noticed that dry hopping at colder temperatures would reduce this, and that was equated to less yeast activity, which obviously makes sense. Less activity of yeast after these dextrins have been broken down, then less hop creep. Now, of course, if you took that packaged beer and warmed it back up, then hop creep starts right back up. So not really a solution, but also the time on hops was a factor. So the further or the longer that the hops were in the beer, the more the more hop creep we see here. So now you can remove the beer from the hops, or get the beer off the hops, or take the hops out of the beer. But that doesn't necessarily mean this diastase is still in there and is still active. But there will be less of it if you remove it earlier. So, whoops, wrong button. Let's see. Yep. So the most recent research that's really been published out here is looking at these enzymes in Cascade hops and trying to come up with a way to screen the hops that you get in your brewery for these enzymes. That way you can know beforehand if you're going to have an issue with hop creep or not. Now there are basic alpha-amylase enzyme assay kits that you can use to do this. We won't get into detail on that, but if that's something you're interested in here, you just want to look up this study here, cultivar-based screening of hops for dextrin-degrading enzymatic potential. That's a mouthful. And what they do is they've used HPLC to confirm that there are indeed fermentable carbohydrate increases after dry hopping over time. So you've got your normal terminal gravity, or what you think is your terminal gravity. You dry hop, and then you see an increase in carbohydrates over time. And that's the enzymatic activity here. So using high performance liquid chromatography to sort of verify this. They also showed that autoclaved hops at 121°C, nobody's going to do that in a brewery, but it definitely degraded those enzymes, so there was no enzymatic activity. So basically 126 liters here, Morris and Brown, their theory was confirmed by HPLC. Kind of interesting. So what does this all mean? We touched on these as we kind of went through the existing research, but the intensity of hop creeps, as I just mentioned, it is related to the time on hops. So that's something definitely that you want to consider if you're looking at ways to mitigate this in your brewery. As I mentioned also, amylase is found in the vegetative matter. So what does that mean? Things like type 45 pellets, which have less vegetative matter in them, may be a better option for your brewery when it comes to dry hopping, or at least bringing down some of those, that enzymatic, the hop creep activity. Yeast must be present and active in your beer to have this hop creep happen. Again, if you had a beer that had no yeast in it, you'd still get the drying out of the beer, but there would be no yeast to act on these smaller chain sugars. Kind of a smaller factor though is that hops will add iron and manganese, which are yeast activators, which isn't necessarily a bad thing, because the health of your yeast, if you've got healthy yeast, you've got a healthy fermentation, and when it, not in a package, but when it's in a fermenter, the healthy yeast will speed it through this hop creep here. So diastase is denatured with yeast, as we said earlier, but obviously nobody's going to kiln their hops at 121C. And then both pH and temperature matter. I took a note earlier here is that it's the pH is optimal around 4 to 4.5 for hop creep, which is not great for brewers because that's right about where our finished beer is. And then temperature wise, it's 60, 70 degrees Fahrenheit. Again, that's usually where a lot of us are dry hopping these days. And it is varietal dependent, as I said. I hate to say it, one of my favorite hops though, Amarillo, seems to be sort of one of the prime candidates for this. But it's better to know that in advance than to go in this blind and not have an idea. So the real question is do you try and battle hop creep in your brewery, or do you accept it and just kind of adjust? I put embrace here. I don't know that any of us are embracing the extra activity in the brewery, but I think you know what I mean. So methods for fighting hop creep. Again, we said here we need yeast and we need beer on hops. So obviously filtering or centrifuging is a way to get the beer out of the yeast. This is centrifuge here from Worthy Brewing, where I used to be brewmaster at. That's not why we brought it in there, but it is an active way to do it. So again, this does not remove the diastase. That is still active in the beer. So you'll still have this continued drying out of the beer, but potentially not the ethanol production and CO2 production or VDK production that you would see. So there are some sort of longer term issues to consider in there. Sterile filtration also would remove the yeast, obviously, and is another option. Pasteurization is an option that I didn't really think there was anyone doing. Again, on the BA Talk, which I encourage everyone to go find and give a listen to, although that's a 2-hour version of this, goes into a lot more detail about how different breweries are dealing with hop creep. But pasteurization, flash pasteurizing, I'll get that right, kills the yeast and also denatures the enzyme in the beer, so thus stops the hop creep. It's a little bit cost prohibitive to most smaller breweries, and then there is a bit of concern about flavor effects, especially from craft brewers. Although again, if you go and watch the BA thing, they do show some pretty interesting sensory before and after flash pasteurizing, and those guys have won a ton of awards, so might be an option out there. And then coarse filtration helps to get the beer off the hops, and then as we said, less time on the hops will decrease this enzyme activity. Another option is dry hopping during fermentation. This is specifically geared towards the diacetyl production. Obviously, if you've got yeast in present, which I know goes against what we looked at before, and I will say that there is no one silver bullet, one solution for fighting the creep, and it's going to take every brewery to look at their individual, what they do normally, what might work for them as well. But the yeast will, if you dry hop during fermentation, yeast metabolizes diacetyl. You still got the over attenuation potential, but that can be adjusted in the mash to some degree. You could lower dry hopping rates, or change variety, or even change the type of hops. So downstream products will have less hop creep potential. But again, now you're changing a recipe, and that's, like I just said, something that each brewery is going to have to kind of weigh on their own. It's not really an option for existing recipes. It takes a lot of work, which is what we were just trying to avoid with reducing the hop creep. But and again, it doesn't account for year-to-year changes, or varietal changes from year to year. So if you've got a beer that you change one year, you may find out next year when you've got a new lot of hops that you've got the issue again and have to change it again. So I don't think anyone really wants to be changing recipes to that extent on a year-to-year basis. If diacetyl is the main concern here, then there's definitely ways to control for that. Normal ways that you would control for reducing diacetyl in your beer is to minimize your DO, to limit those precursors, VDK diacetyl precursors. You can also use ALDC enzyme, with which, if you're not familiar with, I'll show you something here on the next slide. But what that does basically is break this down to eliminate the precursors for diacetyl, but it does not control for CO2 and alcohol increases. But if you're not seeing a huge CO2 increase, and you're thus not also seeing a large bump in alcohol, and it's just really your VDKs that you're concerned about in your beer, then ALDC may be a good option for you. BSG, shameless plug here, carries it from Murphy & Sons. I am not going to go into dosing on this. I would recommend speaking with your sales manager. They're definitely way more well-versed in this. I can tell you from my anecdotal evidence, talking to brewers, that I have seen using this on the higher end, dosage-wise, has been what has worked for folks, and that it is dependent on the hop dosing rate, dry hopping rate as well. So higher dry hopped beers are requiring higher use of ALDC, but it is an option to cut it down. Again, anecdotal evidence, have not heard from brewers that, or have heard from brewers that the higher levels of this, even beyond, which I'm not recommending you're doing, but higher dosing rates of this didn't really have any negative effects flavor-wise on the beer. So the other option then would be, how do you embrace hop creep? And the real question there is can you embrace hop creep and have your beer remain true to its style, remain true to its brand, the way you want the beer to be? Again, adjusting for VDKs and diacetyl, eliminating DO, rousing and mixing during dry hopping will certainly help keep your diacetyl down. But another thing to look at is to increase your the ways that you're testing for VDKs. So UV vis is obviously better than a force test. And what we're looking at is if you're trying to trace hop creep or indicate that hop creep is going to happen, you're really looking at VDK levels that are under 20 ppb. And that's traditionally not really in the normal ASBC testing guidelines for VDKs. So you need to improve your methods. There's ways to do that. We won't get into all that here, but glad to talk to you about it. And again, I can turn you on to some brewers that, Freem, for example, that have come up with some fairly inexpensive and pretty easy ways to test at lower levels of VDKs. But you want to improve it. If you're just doing a sniff test, that's probably not really going to cut it if you're running into hop creep issues. And then consider the enzymes that we just spoke about. You can adjust your gravity in your mash. This does not work to the extent that I would hope. It's been something that brewers have tried earlier, even adding things like lactose to a beer to just, account for the higher attenuation that they would see to add body back to the beer. But adjusting your mash in that way is not really a great long-term. In conjunction, again, there's no silver bullet, but in conjunction with some of these other things that we've talked about may actually be an option for you. But you can also adjust your dry hopping profile. Is there a way to do that and not change the flavor and aroma of your beer? That's really going to have to be something you as a brewer decide for yourself. But using different hop products, downstream products, type 45 pellets are a great option. Looking at the varieties you're using, again, if you've got Amarillo in your beer and you're doing it at 3 pounds per barrel dry hopping, you might really want to consider that you've got some hop creep going on. Look at the addition, the time of your addition. Again, if the hops are on the beer, or the beer's on the hops, better, for a longer period of time, then you really are going to have a bigger issue with hop creep. We talked about the Alphaamylase testing that's available already. It's pretty simple testing. You can test your hop varieties for that. I can turn you on to some research online if you want to shoot me an email that shows you how to do that as well. And then again, adjusting your mash temperature. But again, if you're creating more of those larger dextrins, then you're creating more of a, if you will, food source for the hop creep, hop enzymes to occur. So not a great solution, but all these together really may help act and help you to sort of start addressing hop creep in your brewery. A great resource in addition is this just came out not very long ago. I don't have the whole thing on here, and it's probably hard to read on your screen, but the BA just came out with a technical brief from Shellhammer that it's, I think, about 4 pages long. That goes through kind of what we all did just a second ago, talking about wort fermentability, talking about alpha amylase, beta amylase, where the source of these dextrins are, and then how dry hopping actually creates just basically what we did here. But if you look at the chart on the right, if you can see it here, there's some fairly significant changes in a beer with and without dry hopping. Specifically, where are we looking here? Yeah, it's that alcohol content. In the example they've got went from 6.42 to 6.92, so that's a 0.5%. That gets you out of spec, and again, those 2+ CO2 volumes increase is really a challenge. So something to be concerned about, both regulatory and also safety. So with that, that's pretty brief overview, but I am glad to sort of answer any questions that anyone has here. My email address is on here. You've also got the email that came out that you can shoot questions over to. And glad to, yeah, I'll stop sharing my screen here or just leave this on. Jake, what do you think?
Go ahead and leave it on so people
Sure.
can copy that email address if they want. Great talk, Chad. I think as you said, there's a lot to digest here. So I would encourage, once we send this recording, we'll have it on our YouTube channel, and that link will be on the webinars page. We go back through if you need to reference some of those resources that Chad was talking about. During the talk, we got a few questions, so
Sure.
I'd like to pass those along and do a little Q&A here. The first question was, I think this was generally, has there been similar observations with cryo hops? So essentially downstream, those products that have with less bract, less of the leaf material. Do they see the same things happening in terms of hop creep?
Not to the same extent. So cryo type 45 that we sell, like German Amarillo, although we can do pretty much any of those varieties in T45. Real briefly, the process is pretty much the same for either of those, but it's done in super cold processing. They use liquid nitrogen to basically freeze the whole hop cones, and then shatter off that material that we're not after. The Brax, high in polyphenols, and now, as we know, also higher in these hop enzymes, and that is removed. So that's why it's basically a concentrated hop product. But those T45s, cryo, same thing. But by removing that vegetative matter, they have seen reduction in hop creep for sure.
Gotcha.
So it's something to consider. It does change the flavor profile of your beer. So again, if you're developing a new recipe, that's different than trying to fix an issue you've got with an existing recipe.
Gotcha. Next question was, do we know which starch degrading enzyme is more concerned here among the hop diastatic enzymes?
Let's see if if I have it on. I mean, it's an alpha amylase, essentially. No, I don't think I have it. Can I go back? I don't think I put it in this one.
This is probably a case where I should probably interrupt you and ask the question while you're giving the presentation.
No, that's okay. I can't remember how detailed we got in here, but yeah, I mean, there's really, yeah, I've just got that there's a mixture in here. There's a number of them. I mean, it is basically an alpha amylase, just the same that's in malted barley, but certainly not anywhere near the same level that you'd find in barley. But it's essentially the same thing. So, and I don't think I've got any, yeah.
Okay.
Yeah.
So then the third question was, is diastase carried into advanced hop products? So I suppose it rolls right into the cryo hops and downstream product stuff.
Well, so to speak, the more advanced the hop product, the less it has of this issue, to the extent where CO2 extract, for example, has no hop creep, no diastase, or no potential here whatsoever. You're not going to use CO2 extract as a dry hop, though, so of little value there. But in general, with extraction methods, and I honestly, I'm not sure about some of the distilled hop products that are out there. That would be interesting. I don't think those have been explored as much, but the type 45 and the CO2 extracts have been looked at. Yeah.
Gotcha. Got some more questions coming in here, some really good ones. Here's a really good general question. So from one of the viewers, nano brewery setting, in your opinion, embrace or fight?
How much time do you got on your hands? Yeah, if you're a nano, you're probably doing everything from the books to packaging to distribution. If you're a newer brewery and you're developing newer recipes and you can embrace that and anticipate it, then it's okay. You know that the beer is going to dry out. You know that it's potentially going to take a little longer. If you're just, your back's against the wall with production and you can't let a beer sit in a tank a little bit longer, you can't afford that time, then you're going to have to come up with ways to kind of fight it. Alternative hop products are certainly enzymes. The ALDC is great for controlling the VDKs. It's really going to depend on your specific situation. And I honestly am glad to help walk anyone through this. They want to email me. That's my contact. We can kind of go look at specific. I want to get into one brewery specific. Well, what's your day like? So, but I'm glad to walk anyone through some ways to try it. Yeah.
Fantastic. Here's another one that I think is a good kind of general question. Any idea how soon the effects of dry hop creep could be seen in package? So I suppose is there a general rule of thumb that this, it may start to show up, X amount of weeks into being packaged, or is it
Sure. Yeah, definitely
style dependent?
Sure. All right. I wish I had another slide on this to get into this detail, but imagine, if you will, a world where if you're looking at a chart, and let's say you're dry hopping, and these hand gestures probably on a little tiny screen aren't helping me at all, but if you're looking at a chart that's slanting downward to the right. And that's indicating that your gravity, basically. You're taking a gravity every day on this beer. And day 7, you dry hop it. If you took a gravity immediately after that, like I said earlier, you'd see a small bump. So there are some carbohydrates in that hop material that will contribute to the gravity in that beer. It's minuscule, but it's there. Next, what you would see is this flat line of your gravities to just start slowly, and that's why it's called creep, unfortunately, slowly go down over a week. And it looks like it's about a 2-week process. Again, it's going to depend on how long the hops have been in the beer, or beer on the hops, what kind of yeast levels you have in your final packaged product, what variety. Again, it's hard to, and I think as time goes by and research progresses, we'll have better answers for how all of these minute factors contribute to this. You know, what's the biggest thing? Is it a variety? Is it the volume? Is it the time? What's the biggest factor here? So it's hard to answer, but it looks like it's about a 2-week process. At least that's what I've seen. So you'll just see this just slowly creep for 2 weeks. The best way to know that you're going to have hop creep issues is to measure VDKs, though. That will happen fairly immediately after. As soon as these larger dextrins start breaking down, fermentation starts again. The first thing that happens in early fermentation is VDK production, right? And that's why in a traditional fermentation, you're leaving your beer on the yeast longer to let it break down those VDKs, and thus diacetyl is going at least below threshold. And what you'll see is a very slightly uptick in your diacetyl. And that's why I was saying, if you can measure it in a lab as opposed to trying to do some sort of forced sniff test, which is what I did in my breweries for a long time, that's the best way to know that you're going to run into an issue with hop creep in a particular beer.
Yeah, and I guess just as a follow-up to that, it kind of this question a bit relates back to the nano brewery and what your setting is. It probably depends on the turn rates of the beer. You know, how fast you serve it. Is it going through your tap room? Is it going into a bottle, to shelves, to a distributor? In terms of
that's true too. If it's on draft, you know, and you're doing, you know, I don't know, a few kegs of one beer, and it's getting churned out in your pub or in a tasting room in, you know, 4 days, don't sweat it. It's not a big deal.
Right.
Yeah.
Right. I'm going to go for one more question, and it's kind of a long one.
Okay.
But it's good. It's and again, if I missed your questions, guys and gals, you know, you can email Chad directly, or you can email us at webinars@bsgcraft.com, and we'll pass those along to Chad. So here's the question. Apologizes for length in advance. Based on this info, one could lower the temp of dry hopping, reduce enzyme extraction, and have minimal yeast activity, then run it from a fermenter through a filter to remove yeast and into the serving vessel. What would be an optimal cold dry hop temp that would still avoid extracting vegetal flavor from hops, which I found to be very prominent when hops were added to the keg at refrigerated temps?
Correct. So unfortunately, the lower temperatures that I've seen where these enzymes are not as active. So the lower the temperature, the better. So if you would traditionally dry hop at 66, 68 degrees, you know, normal ale fermentation temperature, if you can get away with 60, that's great. But as we know, the lower you're going through there, you get more of this polyphenol sort of, you know, green flavor that we're not really after. We're after those big fruity bombs. Unfortunately, what I've seen has been more in the like 48, like the lager temperature. But I think the combination of what this person was talking about is a great way to start approaching this. And again, it's going to take a step-by-step trial. Now, actually, I hate to say this, would be a great time to start experimenting with how you may approach this with just the way the world is right now. because you've got some more time to do that. When your back's against the wall with production, you're going to throw all these things at it at once, and make a lot of changes, and that's never great in sort of a experimental method. It'd be great to make one of those changes. Let's say try dry hopping at, if you're fine with 60, do 60 degrees.
Right.
And then compare that with what you've got before. It's going to take time to sort of compare these to, beer 1 to beer 2 to beer 3, and then maybe add filtration. But I think the combination of those two things is a great way to start approach it. And every beer, every brewery, every change in a lot is going to have different levels of this activity. And it's something you're going to have to be constantly adjusting for. So if you can do these experiments now, when you're perhaps not as busy as you were before, you're ahead of the game. You've got more information. So when it does occur next July, and praise be, we don't have this anything like this going on again, and you're cranking out beer, and everything's going great, and you've got to make a change, you're kind of ready for it.
Right. Which I guess it really underlines your point sort of, near the end, is you have every brewery's got to make a decision whether how hard they fight it or how much they embrace it, and then come up with some kind of systematic way to mitigate the problems, because you are going to have those variables from year to year.
Correct.
Yeah. But so you have to, the system has to be there as much as, from crop to crop.
Yeah, it's just important, and what this kind of overview did here, I mean, it's fairly short. There's certainly could spend 2 hours on this and go through, in detail each step where how might you use ALDC. I mean, frankly, if you're using ALDC, like we were just talking about, where you're leaving your beer in a fermenter on yeast longer, you don't have that problem anymore. You could crash it at a specific terminal gravity. As opposed to letting that hop creep carry out. You can get it off the yeast, you can get it off the hops faster. You don't have that VDK issue. But yeah, you can really, it's going to take some trial and error to figure these things out. And like I said, I'm glad to help anybody walk through kind of where to start, look at individual cases, and try and help folks work through these. There's lots of people doing lots of different things. I think I've heard pretty much all of them. So I'm glad to save you the headache of having to reinvent the wheel here and start from square one. So,
well, that's awesome. Thanks, Chad. Thanks for your time. Thanks for your expertise on this. Again, as Chad said, his email is in the webinar slide there, and we'll be recording this and sharing it. So you can email Chad directly, or you can email us at webinars@bsgcraft.com, and we'll send questions along Chad and keep this dialogue going. As always, BSG is here to serve you. So like Chad said, no need to reinvent the wheel. From everybody here at BSG, I'd like to thank you for attending the webinar, and we'll see you next time. Cheers.